So this is a little practice sheet on 1.1 through 1.4. I gave a quiz on it last year, but I'm not going to do that this year. I'm going to roll it into a big chapter test. But anyways, let's see here. We're supposed to find f of negative x plus 3 minus 2. And I'm going to line this up with af's of b times x minus h plus k. Now the order you're supposed to do things is called Bahak, B-H-A-K. And if you look, and I know that not everybody can do this, and I don't understand why, but there's a negative sign, there's b. b is negative 1. And I really don't understand why that's an issue, but it is. It's a big issue, and you need to work on that if you're that kid. If b is negative 1, what you are doing is you are performing a horizontal reflection. Okay? Now what that does is that multiplies x by negative 1. So I'm going to go ahead and do that. Okay? Here x is 2. If I multiply it by negative 1, I would be right here. Here x is 0. If I multiply it by negative 1, I'd still be right there. Here x is 5. If I multiply it by negative 1, I'd be negative 5. And here x is positive 5. And I'm not going to connect all my dots yet here. Thankfully, there's only 2 more transformations. Next transformation, if I follow the correct order, is h. And you'll notice here that h is not positive 3, it's negative 3. So that is a shift x left 3, or subtract 3 units from it. So let's subtract 3 units from it. That put me there, there. Can't do that one. There. Oops. And then there. Alright, last transformation that's actually present. There is no a value. Like it's f. Okay? There's no f. K is negative 2. Which means I shift down 2. Nope. Left the f out. Shift down 2. Maybe you caught that, maybe you didn't. Typos do happen. So down 2, down 2, down 2, down 2, down 2. And there is my final well, something happened here. Oh, I'm connecting the wrong dots. There we go. This one shouldn't have been moved. You can tell it's early. There we go. This looks better. There's my final transformation. Lines could have been straighter. Apparently I'm struggling this morning. Alright, 2. Perform the following transformations of fx equals x squared in the cumulative order requested. Horizontally stretched by a factor of 3. So again, let's take the long route here and let's talk about our transformation forms. It's af's of b times x minus h plus k. Now if I talk about horizontally stretching by a factor of 3, I want it to be 3 times as wide. b is actually 1/3. No. Yes, b is 1/3. So right now, it looks kind of funny, but it's 1/3 I don't like that. Let's see, this is a square. Yeah, that works. I had a 3 in my head for some reason. We'll call the new one g of x. g of x is 1/3 of x squared. Shift left 3, that's going to be your h. And if you're going to shift left, you're going to do opposite. You got to be careful how you write this, though, because that has to be in parentheses. We're shifting left, so we're going to add 3 inside. Alright, vertically compressed by a factor of half. That's the a value. They're saying that a is a half. So g of x equals a, which is out front, parentheses, 1/3, parentheses, x plus 3 all squared, and then part 4 is to shift down 12, and that's saying k is negative 12. So here's the final function. All 4 of them there. Alright, Fred was attempting to reflect the equation 2 times the absolute value of x minus 3 plus 4 over the x-axis, and he wrote this. And let's just see what Fred was doing here. Two times the absolute value of x minus 3 plus 4. I think that was the original equation. And he wrote negative 2 absolute value of negative x minus 3. And then what else did he write? Poor Fred. Plus 4. Okay, so what did Fred do? Fred actually performed a vertical reflection. He did not perform an x-axis reflection. And this is just plain nonsense. Like, it does nothing. There's horizontally reflecting a V doesn't do you a lick of good. So what did Fred do? Well, Fred did 2 things. Fred performed a vertical and horizontal reflection. That's his error. Now to correct it, you know, you'd be very tempted to just say this. This will be the common error. To say that g of x, new function, is simply negative 2 absolute values of x minus 3 plus 4. And that's not going to do it because they're asking for an x-axis reflection, but let me show you what this does. I think I already actually have it up in Desmos. That's not an x-axis reflection, is it? To do a true x-axis reflection, you have to negate the entire function. There's a rule on these. It says an x-axis reflection, g of x is negative f of x. And of course, only a handful of you remember that, but that's the reality of who I'm trying to teach here. G of x must be negative f's of x. That is how you perform an x-axis reflection. So let's do that. Let's wrap it in a negative. So we have a negative 2 absolute values of x minus 3, and then we have the plus 4, and we distribute that 2, and we get negative 2 absolute values of x minus 3, not plus 4 anymore, minus 4. And that is the true x-axis reflection. Very common mistake that people make. They only negate one thing. And now your favorite part. I'm going to pause. I'll be right back. Alright. So if we do this one piece by piece, we might have a problem. But let's see what we can unify here. This thing is running from negative infinity to 1, right? I love how this thing thinks I have time. With a bar, or the bracket, and then it runs from where x is negative 3 to 3, sorry, negative 1 to 3. I'm missing my negative symbol here. A bracket on the 3, and then it runs from 3 with a parentheses to infinity. Now, there's nothing really wrong with that, but there's a lot of extra stuff here because you had a bracket on the 1, which means that x could be 1, and you had a bracket on the 3. The truth is, on this one, you could have just said negative infinity to infinity, and it would have been fine. Because everything is accounted for. While the function is not continuous, every value of x is permitted or defined in that function. State the range. The range is going to be a little different. If you follow this piece right here, you rise from negative infinity to a value of 2. And there's no way to ride another line from 2 to 3. And then we start over. So let's start with this one. This one is negative infinity to 2, and I know that you may not realize this, but that 2's got a bracket because that line was drawn. So negative infinity to 2. Bracket on the 2. Union with, you make a jump just to the other side of 3. We're not actually allowed to be 3. 3 to infinity. Good stuff, domain is, and range. Alright, list the zeros, the x-intercepts. It looks like it's got 2 x-intercepts. We're supposed to do it as ordered pairs. This was something a lot of y'all missed. Looks like there's one around negative 3.50. And there's definitely one right here at 1, 0. For your y-intercepts, it looks like there's one right here at 0, negative 1. You know, over 20% of my students could not find an x or y-intercept on the last basics quiz. Like, that's supposed to be a skill that only like 1 in 100 can't do. Like, it's not a skill that's supposed to be beyond us. We are in Algebra 2 and we don't know how to find an x-intercept with a graph. Like, you can't be that stupid, can you? And I'm saying that because, like, no, you shouldn't be that kid. Like, don't be that kid. Alright, list the y-intercepts for h of x. And I don't mean that mean, by the way. It's just like wow, you have paid no attention in high school or middle school. Wow. Fix that problem. Oh, I did too much here. Y-intercept actually goes in the next one. Alright. State the intervals for which h of x is increasing. That means that we have positive slope. Positive slope. Don't be the kid who hasn't figured out slope yet. You have positive slope from here to about there, from there to there, and from there to there. So most of the graph has positive slope. Let's see, from negative infinity all the way to 2. Union with looks like negative 1 to 3. We never use brackets on anything other than domain and range. Union with 3 to infinity. So most of the graph had positive slope. By and large, this graph was increasing. Decreasing would be negative slope. And there's only one place on the graph that has negative slope. And it's this guy right here. And it goes from about negative 2 to about negative 1. Nah, I misspelled negative, didn't I? Negative. There we go. Positive. Positive means above the x-axis. It's all positive means, above the x-axis. And the vast majority of the graph here is. Let's just erase that all. Highlighter. Blue. I like blue. All that's above the x-axis. So this little piece right here, we run from negative 3.5 to about negative 1. And we can actually merge these two pieces together because x is allowed to be 3. From 1 to infinity. Remember, this is from where x is 1 to infinity. It's not about y. Alright, ix here. What is f of negative 1? And I'm doing the video now. This is an old sheet. I need to edit it a little bit. So what is f of negative 1? Well, f of negative 1 is saying what is y when x is negative 1. And you can be this dude or this dude. But there's nothing here. There's a hole in the graph. So it looks to me like it's 1. That's what it looks like to me. So f of negative 1 happens to be 1. Moving forward, we got a graphing problem. Graph the piecewise function and state its domain and its range. Alrighty, so let's get to work. Best way to graph a piecewise function is simply to make tables. And of course you know what the thing looks like. Like 2x minus 1 is a line, right? It's a line. We're going to feed it a -4 and a -1. If we feed it a -4, it's going to return -9, because twice a -4 is -8. Take away 1 is -9. If we feed it a -1, it's going to return -2. So I have to go back 4, down 9, and it's going to be open. Pay attention to your inequality symbol. -1, -2 is going to be solid, and there's the first piece. X squared minus 1 is up next. You should know that that is a parabola. It's valid from 0 to 3, so we're just going to plug in a 0 and a 3. You might want to plug in like a 1 just to see, because you're not drawing the full parabola. You're only actually drawing the right-hand side of the parabola. So if you plug in a 0, you get -1. If you plug in a 1, you get 0. If you plug in a 3, you get 8. Open, open. So 0, -1 is open. 1, 0 would be a dot. And 3, 8 would be closed. Or, sorry, open as well. 3, 6, 8. The only reason I did the third point there was to give me an idea of what the curvature looked like. Alright, moving forward. 4. Like this is the one, this is y equals 4, kids. You know, 1, 2, 3, 4. You're just drawing a piece of it. I guess if you need a table, so be it. It's going to be 4s on the y values. And you're giving it a 3 and a 7. So when x is 3, it turns out that y is 4, and that is closed if you look at your inequality symbols. When x is 7, it turns out y is still 4. There's your last little piece. So there's your graph. As far as your domain goes, looks to me like the only thing that we can't actually be is right here, between here and here. There's nothing to find between -1 and 0. Of course, we can't be this piece either. But for the domain, we start close to -4. We run up this line until we hit -1. Then we have to make a jump to the other side of 0. And we can run that thing all the way till x is 3, and there's an open dot there, but this one closed it. So we can run from 3 to 7. And there's a parentheses on that 7, and that needed to be an open dot. I forgot to make that open. Sorry, but I caught it. Alright, range. Range, we can climb this thing from -9 all the way until we hit -2. Bracket on the -2, and then we have to climb up to the other side of -1. And we can climb this thing all the way until we get close to what? 8, but not quite 8 because of that. And there you go, domain or range. Easy peasy lemon squeezy. BRB. Alright, so looking at number 6, I want you to remember that a picture is worth 1,000 words. The picture is what you need. Just remember that. You need the graph. Because the graph is going to tell you where the interesting stuff happens. So, we graph. Now this particular function is a right 4, down 5, upside down v. The reason we graph is so that we know where everything's happening. Because when you talk about a piecewise function, that's where the two pieces kind of separate from each other. And let's see, what else do we also need to know? We also need to know that every time we write an absolute value equation, or every time we solve an absolute value equation, we write two equations. Remember that to solve absolute value, you write two equations. The first is as is. On the second, we change the stuff inside. That's what we do. So, that's what we'll do. We'll break it into two distinct pieces by doing the rule we do for solving. The first piece is as is, so negative And this might be a little interesting. Negative x minus 4 becomes negative x plus 4 and then minus 5. And let's clean that up. Might have been too early to go straight to the bracket. Milbrath needs to wake up. I'm not thinking a step or two ahead like I normally am. So on the first one, we say negative parentheses x minus 4 minus 5. That's negative x plus 4 minus 5, which is negative x minus 1. So that's actually the original equation cleaned up a little bit. Okay. On the second, we change the stuff inside. So we still have the negative symbol, but that becomes negative x plus 4 and then minus 5. Distribute the negative, x minus 4 minus 5, x minus 9. Now, this is always going to be the right-hand side. The one that you don't change, and I know we manipulated it, but we didn't actually change anything about it, its value or anything, is the right side. The other one is the left side. And you can see it's got positive slope, right? It's x minus 9. We need to worry about our domain statements. This function is valid if x is bigger than 4. This one is valid if x is less than 4. But one of them has to have equality, and I'm just going to pick the top one. Only one of them gets equality. All right, graph the following functions and their mothers. First, you'll have to do a little factoring because you have to reveal the proper form. So this is going to be a right 2 up 4. Put me about right there. Slope is 3. Now, that was the kid. I never graphed mom. Mom contains 0, 0, 1, 1, and then negative 1, positive 1. Probably should have done a different color for you. There's mama. All right, this one's going to take some work. You're going to distribute that 2. Now, you have a negative 8. A half squared is a quarter. And then you've got this x plus 3 that's now squared, minus 5. And that is supposed to be a quarter. Negative 8 times a quarter is negative 2. And now it's quite easy to graph. The horizontal reflections and compressions aren't that big a deal because they can always be worked out and turned into vertical components. We have a left 3 down 5. The slope is, initial slope is negative 2. It is a parabola. And there is the kid. Of course, mom contains 0, 0, 1, 1, and negative 1, positive 1. There's mama. Moving forward. Let's see here. We have this 1/3 power, which is the same as the cubic root. So let's go ahead and just rewrite this as a cubic root. Do you know what the cubic root of 64 is? I do. It's 4. This is 4 cubic roots of x plus 1 and then minus 3. The cubic root contains 0, 0, 1, 1 and negative 1, positive 1, and it looks something like that, okay? This kid has been shifted left 1. We got a little too much rooftop on that. Left 1 and then down 3. Puts me about right there. It has a slope of 4, so I have to rise 4 and run 1 both ways. Lost my place. And here's the kid. Alright, next one. Factoring is your best friend. You can pull a 16 from both 16x and 64. And you should know the square root of 16 is 4. There was already a negative sign out front. I know you guys get lost in the calculations. Mom was the arm. 0, 0, 1, 1, 4, 2. That's mama. And the kid has been shifted right 4 up 4. Right 4 up 4. And the kid has a slope of negative 4. So fall 4, run 1. And the kid is still an arm. It's just upside down and 4 times as tall. Ta-da! BRB. Alright, I remember this one being really bad last year. Recursive rule is given. Write the first 5 terms. Well, this is the first term, and this is the difference. So the first term is actually given to you. It's -2. The second term is to take the previous term, because that's what that means, and add 3. And that's going to give you 1. And the pattern here is simply add 3. So 1 plus 3 is 4. 4 plus 3 is 7. 7 plus 3 is 10. Convert from recursive into explicit. So the explicit form is that a sub n is a sub 1 plus parentheses n minus 1 times d. And I know you don't remember that. That's the hard part, is remembering things. Well, the first term was -2. The difference was 3. And you should be well aware of the distributive property. That's 3n minus 3. And when we combine like terms and put the 3 n's out front, because we're making it look like mx plus b, this is what we get, 3n minus 5. All right, express 2n minus 3 as a series. And it says just write out the terms 1 through 4. If I want the first term, I feed it a 1. 2 times 1 is 2. Take away 3 is -1. If I want the second term, I feed it a 2. 2 times 2 is 4, minus 3 is -1. If I want the third, 4 minus 3 is +1. If I want the third term, I feed it a 3. 2 times 3 is 6. Take away 3, I get 3. Notice the difference here is 2. The last term, I feed it a 4. 2 times 4 is 8. 8 minus 3 is 5. Why is this thing beeping? Be right back. I got something beeping at me. It's getting annoying. Anyways, that's what it was asking you to do. Express it as a series. And the series just has the plus signs instead of the commas. You're not expected to answer it. You're just writing it out. That's all you're doing. All right, 10. Find the sum of terms 1 through 9 of the sequence 3n plus 4. And we're going to use that 7-year-old's formula that the sum of n things is n over 2 times the first term plus the last one, which in this case is a sub 9. Now, if I think about terms 1 through 9, there are 9 terms. Count with your fingers. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 fingers, kids. So n is 9. Now, remember n, we always do high minus low, add 1 back. You get 9. N is 9. To get the first term, we feed it a 1. So 3 times a 1 add a 4 is a 7. To get the last term, we feed it a 9. 3 times a 9 plus a 4, which should be 40. And then I just feed this thing. So the sum of 9 things is 9 over 2 times 7 plus 40, which is going to be 47, right? Let's see. Sum of 9 things is 9 over 2 times 47. Then we do some math here. This one's not going to be pretty. 9 times 40 is 360. 9 times 7 is 63. That's 423. We can cut it in half because there's over a 2. And I guess if you cut that in half, you get what, 211.5? You should probably check me on that. I don't know. I don't think I did anything wrong. Number 11, how many terms of the arithmetic sequence 1, 5, 3, 5, 7 will give a sum of 961? So what we don't know is we don't know the last term. Okay, so let's think about Gauss's formula. N, not a clue. First term, got her, she's 1. Last term, not a clue. But, and hear me out, the explicit form is literally called a sub n. So let's write a sub n. A sub n would be the first term plus n minus 1 times the common difference. So a sub n is 1 plus n minus 1 times the difference of, looks like 2. And then there's the distributive property. N minus 1 times a 2 is 2n minus a 2. Combined like terms, we have a 2n minus a 1. So I have quite a bit of stuff actually. The sum of n things is n over 2. First term is 1, plus, here's the last term, if only you knew n, 2n minus 1. Of course, the 1's cancel. The sum is actually known to be 961, and it would equal n over 2 times 2n. 2's cancel. 961 equals n squared, which means n is the square root of 961. What do you think the square root of 961 is? Pretty sure I know it. Don't be surprised. Is it going to be bigger than 30? Is it 30? What is it? Should be 31, but I can't seem to wake up today. And it is 31. Anyways, there's your practice sheet. Hope you enjoyed it. You probably didn't. It's math. Nobody wants to do math.